Okay, so here's part five. Now, part five, I'm not going to go through these answers verbatim. Like, I'm probably not even going to write anything down, or maybe just provide maybe a sketch to maybe aid my conversation. But again, this is just a conversation. So the best way to answer this type of question is just pretend you're talking to someone about it, and you're just kind of recording your conversation. Like that's all you're really doing here. And so if you look at the first question, explain whether or not translations, rotations, and reflections are rigid transformations, and whether or not they change the size of the object they're transforming. So a good answer here would involve two things. One, it would be answering the question directly, but then also kind of talking about like how you know they're rigid. And so if you think about translation, rotation, reflection, the real question is like the hidden question is, what about their structure? It's like what about the structure of the motion actually maintains the rigidity? Because in the end, structure actually does come first. The rules come from the structure, so the rules is not going to provide a good argument here. And again, going to have to definitely you're going to have to provide something about the structure. So if you think about the vectors of a translation, like what about what the vectors do in a translation force the object not to change? Think about a reflection. Like what about the structure of reflection forces the sameness to happen? What about a rotation? Like, what's got to be true about how you rotate an object that keeps the distances the same? And so, in the end, it's always about the structure. So, to answer this question really well, you'd have to go back and review the structure of each of these, and then think about how those structures maintain distances. So, here's where things like parallel and perpendicular, bisector, and circles even would come back into the conversation because those structures, the way they're formatted in translations, rotations, reflections, will actually keep the shape the same. So you gotta have to kind of tie that bridge together. Okay, but that's what a good answer would also include. It's like what about their structure maintains the rigidity? The rule is weak. So I would really, even though I know I put rule here, I would really say that is a sad way to argue it because you're going to run into basically a numerical argument that you're not going to be able to prove really well. So I would say to answer this type of question, well, you're going to have to talk about the structure. So go back, review the structure, come back and answer this question. Um, Now the second part is really kind of straightforward. If they're rigid by rule, they don't change the shape they're transforming. But here's where maybe thinking about the role of these incongruency would take place. Oh, wait a minute, that's what these are second questions asking about. So again, I'm not going to tell you the answer here. We can have a conversation about it. So if you need to explain whether rigid transformations can prove figures congruent, you need to review your answer to number one. So like the best analogy I can give you is out of like a car, and I think several people brought this up like in class. If you have this car and you get into this car and you drive somewhere, you get out, you probably haven't changed. Like the car did not change you. In the same way, let's say like a pregnant lady gets into the car, and on the way to the hospital, she has her baby in the car. Well, was that the car's fault that she had the baby, or did the baby just kind of happen to come and change the lady, right? And so, like that's the thing you got to think about when you think about like these rigid motions. Dilations are not part of this conversation because they're kind of weird cousin. But when you think about reflections, rotations, translations, are they causing anything to be the same, or are they simply moving it to a different location? Like if that lady had the baby in the car, was that the car's fault? Did the car do it? Did the car change her? Or did it just happen to did the change happen to happen while the lady was in the car? And so when you think about the role of these transformations, like that's the kind of context you have to put it in. Like you don't have to use that analogy. In fact, it'd be a little sad. It'd be a little sad to use my analogy on my test for this question, so I'd guard against it. But absorb that, kind of make it your own. And when you think about whether or not you can actually use transformations as a proof, think about what it means to be rigid. Okay, and let's talk about this last one. How do translations, reflections, and so this is kind of a reinforcement for the first question. Um, this is talking specifically about the structure. So I would actually say, what's that? This one actually helps you answer part A. And so like they're the same type of question. I could just make it two. But in the end, specifically talk about the structure. Like that'd be my best advice. Don't really talk about the rule. If you want to bring in the rule later, you can, but you got to talk about the structure, right? But anyway, like I said, it's not really fair to me giving answers for this, so I'll kind of leave you with that conversation. But that's it, guys. So that's the key. The key, along with the review and these videos we posted, I always like to cross post. So they'll be in Edmodo, they'll be in my homework, they'll be in our Google Drive. All right. That's it, guys. Part 5. I'm uploading these guys. Enjoy.